This is a question from 2022 IIT Advanced. This question is on players. There are two players, P1 and P2, playing a game against each other, and in every round of the game, each player rolls a fair die. You read this question in detail on your own. Keep this particular question noted on your notebook, and then we can proceed with the solution. I hope you will refer back to this particular question by getting back in this video, and we can solve this question in four parts. As I have written here, there are 5 questions coming up on this particular passage. There are 5 questions. Let's begin one by one. Question 1 says, if capital X2 is greater than capital Y2, then what is the probability of that? X2 greater than equal to Y2. The question number 1 begins like this. The probability of X2 greater than equal to Y2. Probability of X2 greater than equal to Y2. This is the question. What exactly is X2? Capital X2 will be, according to the question, the score of P1 after 2 games. That means there are 2 games that has happened, and let's say X1 and Y1 are the scores of the players in the first game. X2 and Y2 are the scores of the players in the second game. This is for player P1, this is for player P2, and in that case capital X2 would be equal to X1 plus X2, and capital Y2 would be equal to Y1 plus Y2. This is how it would go in the calculation. Now, what is the probability for the net score to be greater for P1 than for P2? How can this happen? This can happen in several ways. One of them can be something like this, that let's say in both the games, P1 scores more, and this comes with an ending. In game 1, P1 scores more, and in second game, P1 scores more. In both the games, P1 scores more. And there is a probability for each of them. Each of these, X1 greater than Y1 or X2 greater than Y2 or any Xi greater than Yi is basically an event whose probability would be counted. Now, what is the second possibility? If the total score has to be greater, say this is a 5-0-5-0 combination. Now, it can happen like this, 5-0-0-5, that would bring it to equality, which we need, but later on we will take it. Another possibility can be where the scores of P1 is greater in first game, and in the second game they get equal scores. Still P1 wins, I mean capital X2 would be greater. But in how many ways can this event occur? This event can occur in 2 ways, with equality coming first and inequality coming second. Then there is one more possibility. There is no other way that the score of X2 can be greater than Y2. Greater cases, finished. Now equal to cases can be of how many types? Equal to cases can be like this, X1 greater than Y1 but X2 less than Y2. See the scores here. 5-0-0-5 brings it to equal score for both of them, but this can happen in 2 ways, this happening first or this happening first. There is one more possibility where each of them get same scores, and this can happen in only one way. Hence we can write it spaciously like X1 equal to Y1 and X2 equal to Y2. This is a possibility. So these are the 4 different cases in which we can get. These are the cases where X2 is greater than Y2, and these are the cases where X2 is equal to Y2. See, these are the cases. Now, how do we calculate them? Let's calculate this. Any Xi greater than Yi. Now let's say your Yi score is 1. That means Xi can be 2, 3, 4 and 5 and 6. That means there are 5 possibilities plus let's say yi is equal to 2. If it is 2, then I have 4 possibilities. If yi is 3, that means I have 3 possibilities. Yi is equal to 4 means 2, yi equal to 5 means 1. And these are the possible ways in which yi can be lesser than xi upon 6c1 dot 6c1, in effect 36. So this is the probability of p of xi greater than yi, and that is equal to how much? 11, sorry, 9 plus 3, 12, 12 plus 3, 15. 15 by 36. In effect, this is how much? 3 5s and 3 12s. 5 by 12. That means p of xi greater than yi is equal to 5 by 12 would be equal to the probability of xi less than yi. The same story would go in the reverse order. And that means for any two scores xi and yi, there are only 3 possibilities: xi greater than yi, or xi less than yi, or xi equal to yi. Now, 2 cases taken here. That means probability of xi equal to yi can be 1 minus 2 times 5 by 12. 2 cases of this, 5 by 12 subtracted from the total, that means 1 minus 5 by 6, that means it will be 1 by 6, or alternately, this can be alternately also seen like this. How many scores are there? Only 6. 1, 2, 3, 4, 5, 6. Each of them occurring 1/6 times against the other, and 6 such possible cases lead to the same result. This is a basic set of calculation which we will require in this question. Now let's get to this calculation. In this, p of x2 greater than equal to y2, p of x2 greater than equal to y2 would require calculations for this. Here we begin. x1 greater than y1 means 5 by 12 and means another 5 by 12 plus 2 times 5 by 12 and equal means 2 by 12. You can write this equal to 2 by 12 alternately. 2 by 12 plus 2 times 5 by 12 dot 5 by 12 plus this is 2 by 12 dot 2 by 12. So let us do one thing. Let's take 12 cross 12 in the denominator and now begin counting with the numerator, that is 25 plus 4 5s are 20 plus 25 2s are 50 plus 4, and how much does it bring? 70, 95, 99. 99 by 144. If we do not reduce, now if we reduce 70, 95, 99, 99. Now if we reduce 33, 3 4s are 12, 3 4s are 12, 24, 48, again reduce 11, 16, that brings you 11 by 16 as the answer. This is the answer for p of x2 greater than equal to y2. See this. This is question number 1 and whose answer is 11 by 16. 11 by 16. Yes, this is the right answer. Now, the next question asks p of x2 greater than y2. Second question. This was your question number 1. Now, let's begin with question number 2. Probability of x2 greater than y2. Now, dear, this is very clear. See this. This greater than equal to case included cases of inequality and cases of equality. If we do not count these cases, we will get only this. And that means what we should not count? We should not count this one and we should not count this one. That means from the numerator, 50 would go off, 4 would go off. Hope you understand this. And that means this counting would be equal to 45 by 144. And that means if I reduce by 3, let's say 15 by 3 4s are 12, 24, 48, again reduce 5 by 16. This is going to be the answer for p of x2 greater than y2. See, calculation becomes easy once you are settled into the basics of the question. The second question has an answer of 5 by 16. Oh yes, that is correct. Now I have a third question here which has not been asked in the exam, but still I would like to ask here. What is the calculation for P of x2 less than y2? Obviously 1 minus this minus of this. Now can you see how much is this? 5 by 16. And how much is this? 11 by 16. So if I add up these, how much? How much does it become? 16 by 16, that makes it 1. So what is P of x2 less than y2? How much would that be? This would be equal to exactly 1 minus 11 by 16. That is the case of, so sorry, I'm making a mistake. The case of less than, that means from the total probability, if I remove greater than and equal to, that means if I remove 1 minus 11 by 16, if I remove that, how much does it bring? It still brings 5 by 16. Same answer as this. That means these two events hold equal probabilities. That means the score of P1 greater than score of P2. I mean score in terms of zeros and fives, 2 and 2s and all those things. The total score of P1 would be greater than that of P2 with equal probability of P1 score being lesser than that of P2. That means probability of anyone winning remains equal, but not half. Now, there is a fourth question again here. The fourth question is about three consecutive games. Suppose there are three consecutive games which are being played. Then P of x3 and y3 would be here calculated. So if I go for the fourth question, the question goes like this: probability of x3 equal to y3. P of x3 equal to y3. What are the possible cases? So if we take the possible cases, how can they go? Equal score cases. So P of x3 equal to y3 can hold how many possibilities? Say this. Suppose x1, y1, x2, y2 and x3, y3 are the scores in the respective games. Then how can the total score remain equal? Now if I make it x1 greater, that means 5-0 score. Now what about these two? Let's say I write less than, that means 0-5 score, 5-0, 0-5. Equalized, equal to. Now see, there are three different events which can happen with an ANDing, and that means how many permutations can happen? 3 factorial permutations can happen. 6 ways it can happen. There is one more way the total score can remain equal. If the scores of both the players, remain equal all the time, that means x1 equal to y1, x2 equal to y2 and x3 equal to y3. If this happens, and this can happen in only one way because there is no difference in the scores or different possibilities of the scores, these endings cannot alter and create new permutations. They cannot. And that means these are the only possible cases in which the total score can remain equal. There is no other possibility. How about calculating on this? Then the answer will be 6 times. Let's begin with this. P of x1 greater than y1, that means 5 by 12. Inequality means 5 by 12. Equality means 2 by 12 plus all the three equal means 2 by 12. 2.2.2, 12.12.12, and that's all. This is the total counting. So here what we have as a total score is 12 into 12 into 12 in the denominators, and then 25 into 6 150 into 2 300 plus 8. That means this is 308 by 12 into 144. If we reduce this, then what can we get is 154 by 6 into 144. Then what can we do is 75, 77, here to 3 into 144. That means this can be 77 by 14 3s are 420, 424, 32. This can be the answer for probability of x3 equal to y3. This will be 77 by 432. See this. 77 by 432 is the probability for equal scores at the end of 3 games. Now we have one more upcoming question, and which can be solved in two different ways, a long way and a short way. Now let's go to, now this was your of course the fourth question, as I had told you. Now there is one more question, and that question is P of x3 greater than y3. Let's move to the fifth question. P of x3 greater than y3 would be a very different case than this. That means we need to take fresh considerations about player 1 getting more score than player 2. Player P2 getting less score up at the end of 3 games. Now what are the different possibilities? Let's take a counting. Let us say x1, y1, x2, y2 and x3, y3 are the scores in the respective 3 games, and there is an ending involved. Now how can you make P1 get more score? Now see this. He wins one game, 5-0 score, and let's say settles these two with each other, 5-0, 0-5. Make it equal score at the end of these two games, but this one is his winning part and therefore he wins. He wins in one game and the other two he draws. Now the drawing of the other two can be done in how many ways? And let's say this particular event can happen in 3 ways, because 2 alikes and 1 distinct. So there are 3 possibilities. Or in the next case, again he makes 1 win and the other 2 they make mutual draws, and this can happen again 1 distinct and 2 alikes, and that means in 3 different ways. Now this is a case of a win on 1 game only. Now what can be the next possibility? Let's consider the 3 games again. x1, y1, x2, y2, x3, y3 with an ending. Now here, let's say player 1 wins 2 games. And what about the third? Not losing the third. Losing the third would compensate one of the wins. No. In this case, he makes a draw in the third one. Now that makes 2 wins and 1 draw. This was like 1 win, 2 draws. And this was like 1 win and 2 draws. These are 2 draws. 5-0, 0-5. It's mutually a draw. And that means this can happen in how many ways? Again, 3 ways. 2 alikes and 1 distinct. Any other possibility that the total score comes greater? Oh yes, there is a third possibility. And in the third one, the player 1 would win all the 3 games. And this can happen in only one way, dear. And that's all. These are the 4 possibilities. Now you check out. He wins 1 and draws on the other 2. And he wins all the 3. And there is a possibility that he wins 2 and draws the third. Well, we just need to count on this, calculate on this, and this was, let me tell you, the long way. This was the long way. What was the short way? I will solve it in a shorter way, just here, the short way. Now here it is, the way you like it, the short way. See. Probability of x3 equal to y3 was available to us in the previous question, and it was valued at 77 by 432. 77 by 432. And we know that. And we know that probability of x3 greater than y3 is equal to probability of y3 greater than x3, and that is equal to how much? That is equal to how much means this is equal to half of 1 minus probability of x3 equal to y3. Consider this. The total possible cases, case 1, case 2, case 3, all total added is equal to 1, but these two are equal. So therefore, if I take these probability values as p, then this plus 2p equal to 1. So 1 minus p by half. I mean to say, if I say this is equal to some p, that means 77 by 432 plus 2p would be equal to 1. So therefore, 1 minus this is by 2 would be equal to this, and this can give us an answer. The answer is equal to, the p value would be equal to 1 minus 77 by 432 into half. How much would that bring? Let's calculate it right here. 432 minus 77. 432 minus 77. 355. 355 by 864. This would be the probability of x3 greater than y3 and equal to probability of x3 less than y3 as well. This would be the answer. This is equal to the answer. This is what I'm saying. And what I want you to tell you is this can also provide the same answer. And just let's have a look at that. This is equal to 3 times x1 greater than y1 means 5 by 12. This is 5 by 12. This is another 5 by 12 plus 3 times 5 by 12, 2 by 12, 2 by 12 plus 3 times 5 by 12, 5 by 12, 2 by 12 plus 5 by 12, 5 by 12 and 5 by 12. If I want to add them up, see, 1 by 12 cube, let it remain outside. 125 into 3, 375 plus, well, let's make it like this. This is 12 cross 12 cross 12. So this is 375. 15 into 4, 60. 25 into 2, 50 into 3, 150 plus 125. How much does that make? That makes 500, 400 plus 100, 500, 500, 600, 710. Well, 400, 500, 560, 660, 710 by 12 cross 12 cross 12. Let's resolve. Divide by 2. That means you get 355 and a 6. That means you get 355 by 144 into 6. I think we are here. 14 6, 355 by 14 6, 84, 840 plus 24, 864. You see that? That's your answer. And that answer is by a long way the same answer, the short way, and that means we can solve a probability question the way we want. But what matters is method. When method is long, it takes a long time. This long way equal to long time, and this short way equal to short time. If you have stayed so far, you are an IIT candidate. Stay focused, stay revised. Thank you for your patience. See you in the next question.